Mathematics has many important unsolved problems. Some of them are famous because a large amount of money is offered for whoever solves it. Other times, they are easily understandable, so many have the ability to work on it. It's always a treat when a major mathematical problem gets solved, and one of the biggest was solved nearly 30 years ago today by Andrew Wiles. This problem is known as Fermat's last theorem and has been intriguing the public for centuries. There are no whole number solutions to the equation xn plus yn equals sine zn when n is greater than 2. Otherwise known as Fermat's last theorem, this equation was first posed by French mathematician Pierre de Fermat in 1637 and had stumped the world's brightest minds for more than 300 years. This problem gained so much attention for two major reasons. One is that it has an interesting story that begins in the year 1637. Legendary mathematician Pierre de Fermat wrote a statement of this proof in one of his published books. As a side note, he added the following: "I have discovered a truly marvellous proof of this, which this margin is too narrow to contain. No record was ever found of a proof for this theorem. To this day, we have no idea if he actually had a proof or if it was a correct one. Let's see what the actual statement is. We have the following equation. Fermat's last theorem states that this has no solution for n greater than 2. If n equals sine 1, then many sets of x, y, and z solve the equation. If n equals sine 2, then we have the Pythagorean theorem. Solutions for n equals sine 2 are also infinite and form the side lengths of right triangles." The proposition was first stated as a theorem by Pierre de Fermat around 1637 in the margin of a copy of Arithmetica. Fermat added that he had a proof that was too large to fit in the margin, although other statements claimed by Fermat without proof were subsequently proven by others and credited as theorems of Fermat. For example, Fermat's theorem on sums of two squares. Fermat's last theorem resisted proof, leading to doubt that Fermat ever had a correct proof. Consequently, the proposition became known as a conjecture rather than a theorem. After 358 years of effort by mathematicians, the first successful proof was released in 1994 by Andrew Wiles and formally published in 1995. It was described as a stunning advance in the citation for Wiles's Abel Prize award in 2016. It also proved much of the Taniyama-Shimura conjecture, subsequently known as the modularity theorem, and opened up entire new approaches to numerous other problems and mathematically powerful modularity lifting techniques. The unsolved problem stimulated the development of algebraic number theory in the 19th and 20th centuries. It is among the most notable theorems in the history of mathematics, and prior to its proof was in the Guinness Book of World Records as the most difficult mathematical problem.